This is the factory fitted stereo from my year 2000 Rover 25. At 26 years old, it's not really surprised that it doesn't work. But to be honest, even if it did, there's so much more out there with better audio quality and a lot more power. Class D amplifiers fitted to modern car stereos are a lot more efficient than older Class A or B amplifiers, and that means you get a lot more bang for your buck in terms of volume and efficiency. Modern units can be smaller and lighter, as demonstrated by the fact this thing is pretty heavy. I tasked myself with finding a replacement and then thought, what's the cheapest stereo that has Bluetooth I can find for this car? If you haven't spotted where this is going already, I'll give you a nudge in the right direction. I went on Temu, I spent £7 on this, which claims to be a fully functioning car stereo with 45 watts of output power. We're going to test that, and we're going to see if it actually works, because I'm going to be honest, this box is really light. Let's go! Before we go any further, let's see what it weighs including packaging. About 350 grams, which considering it's a full car stereo is absolutely bonkers. Since CD players have stopped being included in most car stereos, they've got a lot smaller, and I've fitted many of these so-called deckless units to my cars over the years because I use Bluetooth like most people. But for that to be around a third of a kilo is just mind-boggling, and that's including packaging, leads, everything else in there. Let's open it up and see what the actual stereo itself weighs. We've got the stereo, the user guide, an ISO breakout lead. That is quite useful because we can use that for testing. And the stereo itself, I'm chuckling away because it looks like someone's just got a stereo and cut it in half. Or sorry, in quarters should I say. That's absolutely adorable. Less than a quarter of a kilo, and that includes the metal cage. Oh, it's even got a wiring diagram. So you get these ISO breakout leads included, which are great, and removal keys. But you also get a diagram, which is fantastic, rather than having to Google it and work our way back through that way. Let's get on with some testing. You can see here we have our bench power supply, and to give this thing the best chance of making the rated power, we're going to set it to 14.4 volts, which is the maximum rated voltage this unit can handle. We're then going to use these breakout leads to connect it to this rather meaty speaker, which is part of another video, and I've borrowed it for this one. Heck of a magnet on that. I don't think we're going to push that speaker to its limits with this little thing. We're going to work out the maximum output power using a multimeter, and we're also going to check the output waveform with our little scope. Red is the ignition switch, yellow is the power supply positive, and of course black is ground. Oh, I don't know what I expected for the price, but this is that aluminium cable, and yeah, there isn't. You twist it and it just immediately untwists itself, which makes life a little bit more difficult. I'm worried about the quality of connection we're going to get on that, so we're going to break out the soldering iron, I think, and just give them a little coat to help make sure we get a decent, stable connection. I can't even twist them together. Oh, for goodness sake. Right, okay. That's a pain. This type of cable is also notoriously difficult to solder, so I'm not sure how this is going to go. It seems to be taking fairly well. we go. So for the speaker, let's go front right, which is grey and grey/black. Grey and grey/black. And to attempt to make things even easier for ourselves, we're going to use a couple of spade connectors. I'm not sure how crimping them onto that cable is going to go. So again, we're going to lightly coat the wire with solder in the perhaps vain hope it'll give the spade connector something to grip. Because this is the thinnest cable I think I've ever seen. It's just sort of spreading out like hair whenever you touch it. Oh, that's a pain. In theory, that saloon's set up and ready to use. What we're going to do for power is just crimp them in the crocodile clips and use a bit of tape to keep everything insulated. I think I've given this bench power supply a hard enough time over the last year, so let's not short it out. Oh, that's bitten me. Excellent. I'm not conductive. These are cheap Chinese cables and it feels like someone's filled the boots with grease. They sort of slip all over the place, which is really irritating. Yes, I know this tape is the wrong colour, and no, I don't care. So just a bit over the exposed conductor to minimise the occurrence of silly things. So the reason we wired these two together is, one is the trigger that will turn the stereo on when you put the key in ignition, and the other is a permanent 12-volt feed. And of course, as soon as we put power to the stereo from the power supply, we want it to power on. Before we connect the stereo to the ISO breakout loom, we're just going to see what we're set to. I'll get that set to 14.4. Of course, I'm doing all this, and I don't even know if the thing works yet. It may all be in vain. Let's find out. Turn it off. Not that there. Let's see what happens. So we have power. We have 0, 0, 0, 0. Is it that one? Hi. Oh, hello. Bluetooth. An auxiliary in. Okay. It's got two USB sockets as well. One for charging, and the other one where you can presumably pop in a pen drive. And just having a look on the front, we've got a microphone and a mini SD card slot. Sorry, I should say micro SD card slot. Interesting. Well, it does seem to work. I better go and find a source. Okay, I'm back with a plan of attack. We have a 3.5mm to 3.5mm auxiliary lead, and we're going to connect it with a laptop I have just off screen here. And I guess what we need to do before we go any further is connect a speaker. Okay, we now have a speaker connected, we have an input connected. Well, that was quite interesting, because even at as high of a volume as I was willing to go before the distortion was absolutely insufferable, it never really got anywhere near pulling even half an amp from the power supply. Half an amp, assuming 100% efficiency and no other losses, would be 7 watts. but it didn't even get there. I think what we need to do is connect the multimeter and see exactly what kind of power we're getting from this thing. And to keep things a tiny bit more scientific than they otherwise would be, let's use a 50 Hz test tone for this part. So first of all, we're just going to ramp it back up with the 50 Hz test tone to the point where the distortion starts, which is there. And that is, just under half an amp now. Still, not great in terms of power, but at least it's got the speaker moving. Put it on its side. The resistance of a speaker can change as you go throughout the frequency range. However, let's assume it's going to be 4 ohms because that's what this speaker has printed on it, and it tested at 3.8, which is close enough. We're going to connect the multimeter to the inputs of the speaker and see at 50 Hz how many volts we get. That's the point where the distortion really kicks in, so 4.9-ish. And if we go max and see, that's at 63, which is full volume, and we're at 6.7 volts or so. Having just done some quick maths, totally not using the laptop and using the brain I promise I may have, that works out to be about 6 watts at what you would call RMS, which is before the horrendous distortion kicks in. And when we really push things, that increases to about 8 watts. Not quite the 45 watts per channel that's claimed. But I do have to say, unless you like your tunes incredibly loud all the time, 6 watts per channel is probably more than enough, and it's almost certainly more than the original stereo from this vehicle would have produced. This is a pocket oscilloscope, and what we're now going to do is look at that output waveform, both at the level I think is the amplifier's comfortable maximum without lots of distortion, which is around 6 watts, and then again right up to the limit, which was around 8 watts. At lower levels you can see you've got that lovely continuous wave, but if you keep pushing past the amplifier's comfortable limit, you get this. All that's left to do now is the fun bit. Let's take it apart and see exactly what's inside. Looks like it's just held together with 4 screws, and hopefully you don't need to take the cage off because annoyingly it looks like they've not pushed through the blanks for the cage pins, which is going to be a problem later, but we'll worry about that when we need to. My apologies, it turns out today I can't count, there are 5 screws in total. Oh, this one's got a different thread, so we'll keep that somewhere else. I assume that's just holding the RCA connectors to the back panel. Now, this one is also quite a coarse thread, same as the other. The heads of these screws aren't cut very well, so getting a grip on them is quite difficult, but we're there now. Oh. That's underwhelming. Okay, so we look in there. That's a control circuit board for behind the display and all the buttons. You've got the USB connections, the 3.5mm jack, the micro SD card reader, and on the back here is the amplification circuitry, which is remarkably small. Interesting. Okay, let's disconnect this. That's incredibly simple. So this is going to be our Class D amplifier. And then there's quite literally no other active circuitry, it's just passive components. There's a diode, which I assume is for polarity reversal protection, a few capacitors, and then nothing else. From what I can tell, that says YD1028. It's not very clear. There's a bit of text below it, all the capacitors are in the way of, which is irritating. IVLAS. Interesting. And through the magic of video editing, I'm going to pop some information about this chip on screen now. As it happens, I was completely wrong about this amplifier chip. It's not a Class D at all, it's a Class B. The YD1028 is an integrated Class B dual output amplifier in a 9-lead single inline plastic power package. Developed for car radio applications, that's handy. Interestingly, it can operate at up to 18 volts. However, of course, that doesn't mean the rest of the circuitry is designed for that. So the manufacturer has specified test conditions as being a 4 ohm load, which is good. At 1% total harmonic distortion, they reckon this is good for 5 watts. Interesting, okay. So a long way off the claimed power output by the stereo's manufacturer, but of course this data coming from the datasheet will be a lot close to the truth. At 10% total harmonic distortion, they've bumped that figure up to 6.2 watts. And I looked in the manual that came with the stereo, and these are the technical specifications. That's the whole thing. The rest of it's just troubleshooting in various languages. There's no recommendation of speaker impedance. It just says 4 times 60 watts as a power rating with a max current consumption of 15 amps, which is interesting because the fuse is only 10 amps. And it's just generally a little bit of a quick start guide. But there was one thing that I found quite amusing in the troubleshooting section, and that is number 7. The product emits smoke. And the advice is replace the fuse. They've even typed fuse twice, once in capitals, that wasn't just me. If the problem cannot be solved, the internal circuit has been burned. After sales service is required. I'm no expert, but if something billows smoke, you probably shouldn't just replace the fuse and hope for the best. It's normally a sign that something has already gone wrong, and the fuse has popped to protect it. You shouldn't just throw another one in there and hope for the best. I guess it's time to try and put it back together. I was visualising how everything goes so I don't make a complete mess of this. Connect pins on the bottom. So pop that back in there. I remember which way around everything goes now. Oh yeah, that'll be it. Still some thermal compound on there, so we're good to just reattach the amplifier to the back panel. Now those of you with more experience in car audio have probably found 1,000,001 problems with this stereo. My biggest bugbear is these poorly cut screw heads that make removing and reinserting the screws an absolute nightmare. Slight bend in the unit. Oh, I must have leaned on it ever so slightly at some point, but that's it's the most easy to bend stereo casing I think I've ever come across. Not that that's a surprise. And there we have it. Back together and ready to install in a vehicle. Well, I hope you found that interesting, and to be honest, It wasn't quite as bad as I thought it would be, especially when I first picked the box up and it weighed practically nothing. I'm going to fit it to the car, and I'll post an update in the comments in a couple of months and let you know how it's going. If you enjoyed this video, don't forget to subscribe, and hopefully I'll see you next time. In the meantime, take care. Cheers.